All right, so our last adventure for the day, guys, is we are going to be rotating by a non-90 degree multiple, which we already did. So we've got that down, but we're not starting on an axis this time. So we're not starting on an X or Y axis. So we don't have an easy grasp of the length of our radius or our hypotenuse right now. So first, we're going to have to plot our point. So the point we are using is negative 3, 5. So negative 3, 2, 3, 5. 1, 2, 3, 4, 5. So negative 3, 5 is our starting place. We are wanting to rotate that 180 degrees about the origin. The first thing I need to do is create a triangle. So I'm going to connect that point to the origin. That's my new hypotenuse. And I'm going to loosely connect my point to the axis that it's closest to and create a right triangle. So I know the height of my triangle is 5 and the length of the base is 3. So if I wanted to find the hypotenuse, I would need to find do Pythagorean theorem. So with Pythagorean theorem, I'm going to do 5 squared plus 3 squared equals, I'm going to name this z squared. So when we do 25 plus 9, we get 34. So root 34 equals z. I'm just going to leave it as a root. I highly suggest doing this. Otherwise, you're going to have to take all of the decimals of root 34 with you every single time. So for right now, leave it as root 34. So your radius is root 34. I am wanting to take this point and rotate it 280 degrees around the origin. Well, in order to do that, first I need to know how far I'm traveling just to get to the next axis. So in order to do that, I'm going to need to solve for this angle down here. I'm going to name it angle K. I need to know how far I'm going to rotate down to the axis. So how do we find an angle, guys, if I have sides of a triangle? We find it using inverse trig. So in order to avoid using that root 34 in my inverse trig, I'm going to use tangent because that gives me the opposite, which is 5, and the adjacent, which is 3. So I'm going to do inverse tangent, opposite 5 over 3, and that's going to equal my angle K. Now remember, your calculator needs to be in degree mode for this to actually work. So first we are finding, just to give you an idea of steps, find K, which is the angle at the origin. So with my handy dandy calculator, I do inverse tan, 5 divided by 3, enter, and we get a wonderfully long number that says K is equal to 59.0362, yada, 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 yada. Keep all your numbers with you. Keep all decimal. Remember, you're going to need to keep that number in your calculator. Don't clear it out because you're going to want to arrow up and highlight it to use later. So keep that in mind. So now I know how far we've traveled to get to the axis here, just to the x-axis. So I need to figure out, well, how far do I need to go to get 280? So first I'm going to start by going just 180 degrees because I know I'm going 280. So I'm going to find the difference, or find the distance from negative 3, 5 plus 180 degrees. So in order to do that, I'm going to take that K and add 180 to it, plus 180. And that means I've moved a total of 239.036, yada, yada, yada. So I've moved that far around the circle if I add another 180 degrees. So if I move all the way over here, so this is 239.0 degrees of movement, which is K plus 180. So now I just need to know how much farther do I need to go in order to make the complete 280 degrees. So I need to find the difference between 280 and 239.336, yada, yada, yada. So I'm going to subtract the two. So 280 minus 239.036, yada, yada, yada. I'm keeping that whole decimal every time I subtract. Please keep that in mind. It will change your answer potentially. So I'm going to take 280 minus my answer, and that means I need to go an additional 40.9638 yada, yada, yada degrees. So from this x-axis, I'm going to go up. Whoa. I'm going to rotate up an additional 40.9638 degrees and find my new point. Now my radius doesn't change, and I'm just going to sketch out a point. It doesn't necessarily have to go exactly where it's supposed to because this is just a sketch. I'm going to need to move some of this. Sorry, guys. I kind of took up a lot of space. I'm going to take this piece of information and move it down here. There we go. There we go. Cool. Sorry, it was just taking up too much room. I needed it to move. And so I'm going to say, I'm going to be right about here. So we are rotating up to this point. So my angle in here is 40.9638 degrees. And I can kind of sketch down to the axis, create my right angle, and I have my y and x prime that I need to find now. So I still know the radius, or the hypotenuse, is going to be the same. So it's still 34 degrees, because remember, you're treating this like you're rotating around a circle. So you have a radius or a hypotenuse if you make a right triangle. So if I have an angle and I have the hypotenuse, how can I go about finding x and y? Well, we're just going to use trig. So to find x and y, I'm going to set up cosine and sine. Again, we're going to use this entire angle of 40.9638756532, however long it is. So for x, we say the cosine of 40.96, use the entire decimal. I'm just not writing the whole thing out because it's going to take up so much space. Equals over root 34. You know you need to go through and multiply and put root 34 outside the cosine. To get x. And so square root 34, delete. Oops. That's how that works. 34 times cosine of that angle, enter, gives me x, and I'm rounding to the nearest tenth, is 4.4. I'm going to do the same thing for sine. So sine of 40.9 something 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 equals y over root 34. Multiply the root 34 on the outside, and you get y is equal to 3.8. So our new point is hanging out at 4.4, 3.8. 4.4, 3.8. And it doesn't matter if the point isn't actually where it's supposed to be on the graph, as long as you know the actual coordinates. Because trying to sketch that out, it's not going to be perfect. So please just keep that in mind. Okay, so yes, there's a lot of steps to this type. I'm very sorry. But the more you practice it, the more you think about right triangles and how you can create those right triangles is really how you're going to go about solving these. Thanks, guys.